The seed germination process that we described in the last section applies to seeds that are said to be viable. And what viable means is that they are alive and capable of germinating. So viable means alive. However, in many seeds, even if you provide the optimum conditions for germination, they may refuse to germinate, in which case we say that those seeds are dormant. And so let me put down an actual sort of definition here. A dormant seed is a living seed or a viable seed that does not germinate. And what we're going to talk about in this section is reasons why that may be the case. Now, an awful lot of plant species will germinate as soon as they get enough moisture. The germination process gets started. However, many other plants need more than just moisture to get the ball rolling on germination. And a lot of that depends on what is the nature of the seed covering on that seed. The outer layers or the outer testa, and sometimes the inner testa as well, are in large part responsible for this dormant condition. And they can do it in a number of different ways. The first is a case of being impermeable to water. Impermeable meaning waterproof for the most part. I'll just say H2O. This is referred to, if this is the case, as hard coat, seed dormancy, plants that have this hard coat seed dormancy tend to have a very hardened outer seed coat, like many of the stone fruits have. A peach, for example. To get these seeds to germinate requires what we would refer to as scarification, or scarification, you might say. And it is basically the mechanical or chemical breakdown of the hard seed coat. So, out in a wild setting or a natural setting, this may involve animals of various types chewing up these seeds, gnawing through that outer hard seed coat. In a lot of cases, freezing of the soil and the formation of ice crystals. So we'll say ice and soil abrasion will actually wear the seed coat down to the point where it can then germinate after the winter months have finished. In a agricultural setting, or maybe a plant nursery, for example, put a notch with a tool of some sort into the side of one of these seeds to speed up or help speed up that process. So in some way, shape, or form, if a seed has hard coat seed dormancy, it needs to go through this scarification process before it can germinate. Not only might a hard outer seed coat prevent water from getting into the undeveloped seed or the ungerminated seed, it may also prevent germination because of mechanical resistance. In other words, it physically restricts the expansion of volume of the seed. Water has volume, and if we were to drink a gallon of water, our volume of our body would be increased. Water takes space, and the same holds true for even down at a cellular level. If a cell uptakes water, its volume is going to naturally increase. And so if that is restricted from happening, it would be sort of like having a belt that's too tight. Your abdomen can't stretch out if you ate a big meal or if you drank a lot of water, for example. So the same sort of thing can be happening within a seed. And if this is the case, scarification can alleviate that. Oftentimes, if it's not also waterproof, repeated wetting events or repeated, we'll say rain, repeated, let's say wetting and then drying. In other words, expanding and then easing and shrinking down a little bit, and expanding a little bit more. From the inside out, it can actually break its own seed coat in that manner. Another possible scenario is Gas exchange is hindered by a hard, thick outer seed coat. If it's waterproof, it's very likely also not going to allow gases to move through. And the gas that a seed is definitely going to need plenty of, specifically, is oxygen. As respiration rates increase, it's going to require more and more oxygen. So without oxygen, let's say if no oxygen, then respiration is stopped or prevented from happening in the first place. So it might be preventing respiration from moving forward by not allowing oxygen to get to the seed. And then finally, we can also have chemical inhibitors in the seed coat, and this is fairly common. Many plants that have this mechanism built in, it will often be the inner testa that has the inhibitor in it. ABA, for example, is often the culprit. And until these levels diminish by being broken down over time because they're not stable enough to last indefinitely, or somehow be leached away, we can say, which means washed away, in other words, by a certain amount of rainfall or a certain amount of moisture, they'll prevent the seed from germinating. And it's also important to note here that seeds, even from the same flower, will at least have slight variations in the amount of chemical inhibitors in their seed coat. So seeds will vary in, let's say, inhibitor amounts, or inhibitor, I'll also use this as quick way of saying inhibitor concentration. And this ensures that not all seeds, as well as the above dormancy, and this is really the gist of all dormancy and the reason for having seeds that are possibly dormant, is that not all seeds will germinate at once. Now, we might think in an agricultural setting, like at a nursery setting, or if we were trying to establish turf grass, let's say, from seed, or a corn crop from seed, or whatever. In agricultural settings, we usually value consistency, and we would like everything to do it when we want to do it, particularly seeds to germinate. We want them to germinate all at once and simultaneously. Well, that works okay in agricultural settings because we often have at least some control on the resources that those plants are going to need to develop into mature plants, most notably water and also temperatures, because we can control what time of year we plant the plants in the first place, or the seeds, I should say. And so what is the value of not germinating at once? Well, out in the wild, if we have, let's say we had 10 seeds, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 seeds from the same plant, and they were all at the same depth in the soil. If they were to all germinate simultaneously in the spring, let's say, and a late frost were to come through, none of them would survive. The frost would kill them, as it often does young seedlings. However, if they had differing amounts of chemical inhibitors in their coat, which means that maybe these first two would germinate after a certain amount of rainfall, and then maybe there's an extended drought, or even you can use your imagination. Even maybe a deer comes by and nips the tops right off of those plants, thereby killing the seedlings. Well, if that's the case, well, then you've already lost 2 out of the 10. Now, if they had all germinated at once, you would have lost 10 out of 10. But in this case, you still got 80% chance that something's going to happen or something's going to survive. So, a little bit more rain washes enough inhibitors out that maybe these 3 germinate next. If there's another frost or the deer comes by a second time, it might wipe out those as well. And so I think you get the idea here. If there are no late frosts or deer or any other type of potential doom for these seedlings, well, then not germinating at the same time will have been in vain a little bit, but you would have 100% survival potentially. But because these seeds will have differing amounts of inhibitors, it virtually eliminates the possibility that they all will be lost in one fell swoop. And so having seed dormancy and having differing amounts of seed dormancy in seeds of the offspring of plants, in seeds that are going to produce the next generation, is actually a good mechanism to increase the chances that some of those seedlings will survive in the long run.